Good day once again. My name is Mr. Adesanya Ademola. Once again, I'm back here to continue with our lesson that we started some couple of days ago. We started with the topic menstruation, and in the class we consider was SS1. Today we still want to continue from where we stopped last week. I did promise to you that when next we will be meeting, we will look at the second subtopic, which is length of a chord. Now, before we continue, it is expected that at the end of this lesson, students should be able to recall and use formula to calculate length of a chord. Not only that, and that students should be able to solve word problems on lengths of chords with the aid of diagram. Now, let's go to the lesson 2. Under this lesson 2, the content we'll be looking at is length of a chord. Length of a chord. I like us to listen carefully because this is going to be very interesting to as many who will listen. Now, I'm going to show you a diagram. That diagram talks about the length of a chord. Now, looking at the diagram we have here, what can you observe? What can you see? I want to believe that some of us will say that, oh, we have a circle, and inside that circle we also have a triangle, and that triangle has two right angle triangle. Yes, but remember that last week I told us that when you have a straight line that divides a circle into two unequal parts, that line is called a chord. Now, from this diagram we have the length of a chord AB. So meaning that AB is actually the chord that we are referring to. Now, AO is one radius, while BO is another radius. And the triangle we have here is triangle AOB with a perpendicular line OM. This OM divides the triangle AOB into two equal parts. Supposing that the theta is the angle at the center. Now that it has been divided into two, so it shows that each part we have theta over 2, theta over 2. And that is why from the right angle AMO we have theta over 2, and from right angle OMB we also have theta over 2. So meaning that AMO and BMO, they are equal. So invariably at the end of the day we will need to find the length of a chord AB, which is equals to length AM, which is the midpoint, plus MB. Now let's go. Now, first and foremost, we would like to consider a right angle OMB. From OMB, we have this diagram. Don't forget, like I said, that OB is the radius, while OM is the perpendicular line where an angle 90 degree is formed. From the diagram we have here, you will agree with me that the side that faces angle theta over 2 is actually called opposite, which is MB, meaning that our opposite is MB, and the longest side, which is the hypotenuse, is denoted with R. Therefore, sine theta over 2 will be equals to opposite, which is MB, over hypotenuse, which is R. Now from there we now cross multiply. Now when you cross multiply, we are going to have MB, which is equals to R sine theta. We are going to have MB, which is equals to R sine theta over 2. Now, if you also consider the second right angle triangle, which is triangle OMA as well, you are going to have something like this, because we shouldn't forget that from the beginning we have a circle where you have two different or two separate right angle triangles. So we have considered the first part, which is OBM, and we are now considering the second part, which is OMA. Now, the same thing we did the other time, we are going to do it now. Now, any side that faces the given angle is called opposite, while the longest side or the side that faces the right angle is called the hypotenuse. So, and when you are using the Pythagoras, sorry, when you are using the trigonometry ratio, you will agree with me that opposite over hypotenuse will give us sine. Thus, sine theta over 2 is equals to AM over R. So when you cross multiply, you also have AM, which will give us R sine theta over 2. Now, remember that we said that length AB, which is the length of a chord, is equals to AM plus MB. And from our solution, our AM gave us R sine theta over 2, and our MB also gave us R sine theta over 2. So AB will just be the addition of AM plus MB, and that will give us R sine theta over 2 plus R sine theta over 2. Therefore, AB will give us 2R sine theta over 2. So at the end of the day, we can now say that length of a chord, the formula for finding the length of a chord is equals to 2R sine theta over 2. The length of a chord is equals to 2R sine theta over 2. It is very simple. Now let's go to example 1. The angle subtends at the center by a chord of circle of radius 6 centimeter is 120 degree. Find the length of a chord. Again, I'm going to take it again. Example 1. The angle subtends at the center by a chord of a circle of radius 6 centimeter is 120 degree. Find the length of a chord. Now let's look at the solution. From the example given to us, we're given two parameters. The first one we are given is radius, which is given as 6 centimeter. We are also given the theta, which is given as 120 degree. But first and foremost, the first thing we need to do is to write out the formula for finding the length of a chord. Length of a chord is equal to 2R sine theta over 2. Now, R is given to be 6 centimeter, theta is given to be 120 degree. So all we need to do is to now substitute into the formula, which says length of a chord is equal to 2R sine theta over 2. Now, when we substitute, length of a chord will become 2 multiplied by 6 times sine 120 degree over 2. Now, when you divide 120 degree over 2, you're going to get 60. Therefore, length of a chord will give us 12 times sine 60 degree. Now remember that sine 60 is a special angle. And what is sine 60? Sine 60 will be root 3 over 2. So when you multiply root 3 over 2 multiplied by 12, you are going to get 6 root 3 centimeter, because 2 in 12 will give you 6. Then you multiply by 3, that will give us 6 root 3 centimeter. I hope that is very clear to us. Good. Now let's move on to the example 2. Example 2 says, a chord of a circle is 8 centimeter long, subtends an angle of 120 degree. Find the radius of the circle. From the first example, we were asked to find the length of a chord. And when we were asked to find the length of a chord, remember, we were given the radius, we were also given the theta. But this time around, the length of a chord is given to us to be 8 centimeters long. At the same time, the angle that subtends it is given to us as 120 degrees. Here we are asked to find the radius of the circle. Now, solution. The first thing to do is to write out the formula for finding the length of a chord. Length of a chord is 2r sine theta over 2, where the length of the given chord is 8 centimeters and r is unknown. So we now substitute the given parameter into the formula. Thus, we will have 8, which is equal to 2r sine 120 degree over 2. So when you divide both sides by 2, you're going to have 4 equals to r sine theta. Now don't forget that we are looking for r. So make r the subject of the formula. So when we make r the subject of the formula, or better still, you can divide both sides by sine 60 degree. You will have r is equal to 4 over sine 60 degree, which is the same thing as 4 divided by sine 60 degree. And remember that sine 60 degree is root 3 over 2. So r will become 4 over 1 divided by root 3 over 2. So at the end of the day, our r will be 4 over 1 multiplied by 2 over root 3, which is equals to 8 root 3. But we cannot leave our answer like that. So we need to rationalize the denominator. So when we rationalize the denominator, we will have 8 over root 3 times root 3 over root 3. So that will become 8 root 3 over 3 centimeter, because root 3 times root 3 will give us 3 centimeter. So therefore, the radius of a circle is 8 root 3 over 3 centimeter. Now let's quickly look at example 3. In the diagram below, O is the center. Calculate the length of the chord AB if line OA is 5 centimeter, line OD is 3 centimeter, and triangle AOD is equals to triangle BOD. Now this is the diagram. Now we need to observe some things from this diagram. From this diagram, we were not given the length of the chord. At the same time, we are not given the included angle. So how do you calculate it? Remember, we are having two unknown. Supposing we are having only one unknown there, and then we can use trigonometry ratio, especially when the given angle is identified. But here we have two unknown. So all we just need to do is to use Pythagoras theorem. But we are going to start from triangle ODB. ODB has formed a right angle triangle, and from ODB, you will agree with me that we can use Pythagoras theorem, which says OB, remember OB is the longest side, OB square is equals to OD square plus BD square. So OB is 5, that becomes 5 square is equals to OD, our OD is 3, the square it, that becomes 3 square, and plus BD. Now, when you rearrange, the result will become BD square, which is equal to 5 square minus 3 square, which is 25 minus 9. And BD square will give us 16. Take the square root of both sides. So when we take the square root of both sides, then our BD will become 4 centimeter. Now remember that since the chord AB is equal to AD plus DB, and we all know that If our dB is 4 centimeter, automatically our AD will also be 4 centimeter because AO is equals to OB. So they have the same radius. Now, at the end of the day, we will now add AD to DB, and that will give us 4 plus 4. And therefore, chord AB will be equals to 8 centimeter. Now, that is where we are going to stop today. But as usual, I need to give you an activity to do. So this activity will just take about 3 minutes to do. Try and do it. So this is the activity. Calculate the length of a chord of a circle of radius 10 centimeter if the chord is 6 centimeter from the center of the circle. Again, calculate the length of a chord of a circle of radius 10 centimeter if the chord is 6 centimeter from the center of the circle. Finally, the assignment. Calculate the length of a chord which subtends angle 105 degree at the center. Again, calculate the length of a chord which subtends angle 105 degree at the center of radius 3 centimeter. That is where we are going to stop today. When next we meet, we will look at perimeter of a circle and the segment. Please, when you get home, make sure you do the assignment very well and at the same time prepare against the next class. Like I said, the topic we'll be treating against the next class will be perimeter of a circle and segment. Thank you for listening. Till then, I still remain your mathematics teacher. God bless you.